So I'm saving HVAC for last because it's the least important. Uh, this is really a script that was designed just as an exercise, not to apply to a real project. And I know that people have had some problems with glitches, which I totally understand. Let me go through it though with you and see if we can get some useful information out of it on your project. If not, just skip it. I'm not that worried about it. Okay, so the first thing to realize is that the script that I've provided is simply running a Climate Studio thermal analysis. So since we've already run a successful thermal analysis, we know this will work. We're going to use the same zones. So if we go to, all we need is the Grasshopper script. Let's talk about what this script's going to do before we actually use it, and then we'll see what we can get out of it. We have our climate data. As typical, in this case, we have to choose our climate zone. We have thermal zones, windows, ground, shading, just that's all from we're used to from our thermal analysis. You do have to set a path, and this is different than other path settings. We're actually going to a directory in this case. So you're selecting a directory. You have to say, I want it to go to this folder. You pick a folder, you make a folder on your computer so that it knows where to send the simulation. If you don't do that, you'll get some kind of warning here. So just realize that's a kind of a new thing you got to do. Then we're going to get outputs that are comparing 4 different types of HVAC systems, their site EUIs, their carbon footprints, and their annual costs, their first cost, and the size of the system. And then and that's really the most important thing. We can definitely get that output because we can run, we know we can run a thermal simulation in Climate Studio, and that's where this is coming from. Then there's this section over here, which is all about the layout of the ducting and the equipment. That probably is going to be problematic, but it's not that important, and I'm sure we can get something to work in it that will be of use. So let's give it a shot. So the first thing I'm going to do is come over here, and I did make, these are exactly the same thermal zones as I had in my energy use analysis, but I wanted to group them together differently because let me turn off my ground too. So anyway, I'm going to start by selecting all of them, and I'm going to place them in the thermal zone BREP. And before I even run anything, actually, since I've run this before, it remembers it, and so it's running a simulation. It already ran the simulation, and we have outputs. We can come over and see that the ducting is totally screwed up. I can come over and I can change. It's working, so I can change the system, and it will change the ducting, but something super funky going on. Let's not even worry about that right now. And of course, I would have to come add. Let's just go ahead and do that. If I come into my previous thermal model and I add in Windows, I think I have to turn them on, so do that. I can bring those in. I can set my ground, which was here. And I can set this shading. Okay. And I'll just run the simulation. And okay, so here's our outputs. This is a chart comparing, where we have the typical breakdown. This is our energy usage, so it's our site EUI, and we have it broken down into lighting and heating and equipment, etc. Then here, this is really the more interesting chart. We have each system, the system type here, and then we're comparing the EUI. So our VRF with so variable refrigerant flow heat pump with a dedicated outdoor air unit or air system has the lowest energy usage and therefore the lowest carbon of any of them by quite a bit in this case. Um, though its first cost is um, actually less than the uh, fan coil unit, but it's more efficient, but it's more than these others. And this, if you're talking to a developer, this is what they're going to be worried about, and so they may just go, "No, we're using these. We're doing a variable air volume." And if you would have designed for a VRF, you're going to be in trouble because this is much larger. And I can even just show you that. Even though our ducts aren't completely working right now, if I come over here and I switch to the um, from the VAV baseline to the VRF system, much smaller ducting. Let me do something here too so we can see this better. If I come to my thermal analysis, and I'm just going to turn off these previews. This is personal preference, but I like seeing through the building at this level. It's kind of irritating. You have to do each one individually. And I have to go to wireframe. Okay, now we can really see our messed up ducting quite well. Now we can see more clearly if I switch between the VRF with DOAS to the baseline, much larger ducts in the VAV system, and so that would be something that we would need to know when we were initially designing, or if we had designed for a VRF system and our client didn't want to use it, we could be in trouble because it won't work. So this is something we have to be thinking about early on. Okay, but let's see if we can fix this. So my point being, without the ducting working, you can still make uh, get interesting information from this script and make some kind of decision. But let's see if we can get something to work here. I'm going to go and just select individual parts of the building and see if they work in terms of my set a single B-rep. I ran the simulation again. Sometimes you need to do that, and I see that I do have ducting here, and it's making sense. It's not going crazy. So that's my basement. Let me see if I can then just take this one stat side of the building. And we could consider this a separate, not separate system, but it could have different equipment. So this isn't completely ridiculous. And let's see if I can run both of these. Uh, and yeah, that seemed to work. But what I don't have yet is I don't have the roof mounted units. So to install those, I have to put a point on the roof. And this could mess it up. We'll see what happens. Come over here and set this point. Yeah, and that confused it again, right? So, but let's just talk about again what is it that we're doing here? I'm just trying to see if I can sort of get it to behave. Um, it's unfortunate that we're not getting the graphics exactly to work, but it doesn't really matter because let me tell you what this is doing. Trying to get it to come over here more. Sorry, bear with me. See if yeah, it's a little better here, but then it's leaning off the roof. I'm messing around with this too much, just kind of ADD here. Um, all that's going on is that we are dealing with the sizes. So you see down here, a big advantage of this system. So I just had to, I paused and just went and reran it because it was driving me crazy. I got this to work much better. This looks more like a sensible um, HVAC layout for both the basement and this side of the building. But what I was getting at is that you see how these two, the VRF and the DOAS units, where you have a big unit on the roof that's also doing fresh air, are much smaller. The ducting is smaller, and so the equipment is smaller. Um, and that's really what we're modeling here is the size. So we're saying that there's some equipment on the in a mechanical room in the building. That's what this red box is representing. There's some equipment on the roof, and there's a bunch of ducting, and it's going to be different sizes for different configurations of this. So if we switch to the VRF with DOAS, that system does not have any interior mechanical system. It's all done on the roof. Um, or the internal units are in individual rooms. So we have a much bigger mechanical red box in the roof and none below. If I switch to fan coil units, I've got a smaller roof mounted unit because I also have something in the building. So this is just all relative sizing. And the same thing with the ducting. This is just sort of dumbly laying out a certain amount of ducting. Um, so we are learning something from this, even if it's not exactly accurate. And the main thing that we're learning, the main thing I'm interested in is better, is the ceiling heights based on the ducting position. So distance between here and here is what's most important. And the fact that if I change to this, I get a much bigger duct that also may have to go down a little bit because it maybe won't fit because there are other things that need to be above it. So I can mess with that stuff with this script. So for example, I can, let me turn off my windows and just turn this all off. That's a window. Why is that still on? I'm not going to worry about it. Point being, so if I want to uh, adjust my duct height, I can move it up or down here, and that would then, adjust my ceiling height based on what I know is going to happen above that, and that would give me some idea of whether or not this design is going to work in terms of how much, um, you know, air rights height I have or whatever. Um, I can also offset the ducting into the building more or less based on, so if I have a corridor that's somewhat in, maybe it's inside an office or something, I could pull it that further in. I could I can adjust these. So this is like the equipment in here. Like this is the diffuser. See how I can adjust the height of it. So that'd be where the actual ceiling would be probably would be that where that sealer that diffuser is set. I can determine the placement of my return. So I could, I can flip it to the other side, or I don't know why that didn't work, but change its offset because the yellow is the returns, the blues are the supplies. So there's a lot that I can learn from this spatially without knowing the exact layout. But let me just see if I can. So I would say we're done there. I can come over here and measure, um, set up a basic. I can choose my system and then try to determine what my ceiling height would be based on the ducting sizing that I've chosen. Um, and I could do what I'm saying as separate parts of the building. So I could say this is one system, and then I could come pick this system, um, pick these zones, and try to run it with that. Let's see, we have to rerun it. And we see now we've got this issue. It's might be because this was left over from before. And we could do multiple um, rooftop units with this setup. So I can come set both of these as And so that sort of that fixed the layout problem, and now I can, adjust whatever I want to adjust. So that's all I want to do. That's all I want you to know about for this HVAC. Play around with it a little bit, see if you can get it working. Again, the main thing is to make this cost, size, energy usage comparison. If you can get the ducting working, that's great. Um, but I've made it last because it's the least important to me. I just think it's important that you understand the idea that you need to be thinking about the sizing of your or the design of your HVAC early in your design process so that you understand that it's since it has physical volume, it's part of your formal design and there it because it takes up space. All right.